Okay, let's get started. All right. So how about that caramel corn? That'll take your fillings right out. It's really sticky. All right, so thank you all for joining me here today. It's a 20-minute talk. I think I've got about 17 minutes of material, more or less. So, but when you get up and talk, sometimes it goes faster. So, all right. So, testing cloud provisioning with InSpec. Who am I? Why am I talking at you? Why should you listen? So my name's Wolfe. I've been a software engineer for a long time. I was formerly a DevOps consultant, as well as being a software engineer. So you do both at the same time. You get people to try to talk to each other and then automate the parts where they won't talk to each other. I've been a software engineer for about 20 years, combined on Perl and Ruby. Today I only do Ruby, which is, I think, mostly better. Mostly. I've been working with AWS for about 5 years, and for the last 3, I've been doing that mostly through Terraform. So that's been a good time. That's what I'll be talking about. So I'm a senior software engineer on the InSpec project itself. So I helped make InSpec, and I also specifically helped make a lot of the AWS resources that let you access and evaluate infrastructure components in AWS. So if you have comments about that, feel free to approach me after the talk. All right, so what am I going to talk about today? Well, let's just suppose that you are someone who has some infrastructure somewhere in the cloud and that you use Terraform to set it up. Beautiful logo of Terraform, which I finally dug up today. And you are totally on board with having infrastructure as code, or at least as on board as you can practically be, because everything in DevOps is about practicality. So that's great. Your infrastructure is code now. And you've come to realize that code should probably be tested, because it's going to be tested. Whether you write tests or not, it will be tested when it's actually deployed and fails, and then you have to fix it in a hurry, or it deploys and your customers figure out that it's broken, all that sort of thing. Better to test it yourself early and not have everybody get mad at you. So let's figure out how we can test Terraform. See? All right. A motivational example. So I'm just going to say we've got a little bit of infrastructure here. It's in tier, meaning that there's a load balancer in front of an instance. That's about it. It's going to deploy some application, and then we're going to profit and make a lot of money, have an exit strategy, move on to the next big thing, sell shoes or something, who knows. Except we're not actually going to deploy any application, because that would reveal all the secret sauce about how to make the profit. Right? So how do you do just that part in Terraform? Before I go on to the next slide, how many of you have used, as in written, Terraform code? A fair bit. I will move fairly quickly through the next few slides, because these will not be surprising to you. All right, so the first thing that we know is we need at least one instance. So here's how you do that in Terraform. It's fairly straightforward. You have a resource here, so everything in Terraform is a resource or a data source or a couple of other things. And we're saying that we want an AWS instance. We say how big we want it to be. T2 micro, that's the cheapy stuff. What disk image to use for it. A couple of other things that we're not going to worry about. But the two big important things are these security groups and the tags. Security groups in AWS are basically firewall rules. So here we're saying we need to have an instance, a virtual machine, and it needs to have firewall rules associated with it. And we're saying it has 2 sets of them. Also, it needs to have tags so that we can go find it later and explain what in the world this thing is to other people. When I was a DevOps consultant, one of the most common things I would find with a shop that had moved to AWS but hadn't talked to anybody about how to do that, they would have hundreds of instances running with 0 tags. Who knows what anything is? It was great. And they weren't using CloudTrail or anything, so you couldn't even reverse engineer who did what. They just leave it running because it might be important to somebody. Total digression. All right, load balancers. So here I'm just making an old style ELB. There's now 2 new cooler kinds of load balancers you can use, but this is the simpler kind. So this is how you make a load balancer. You give it a name. It gets some other stuff. It also gets a security group because it has to talk to the world, and it gets instances. So we're assigning it to we're assigning the instance that we made earlier to this load balancer. Now then, the real meat and potatoes of a load balancer is what do you do with incoming traffic and where do you send it? This is a very simple listener. It just says listen on port 80. That's the web port, if you didn't know that, and We'll ship them off to the instances that it has behind it in a round-robin fashion. Not a very exciting round-robin because we only have one instance. Bloop. All right, let's talk about those firewall rules or security groups. All right. So they have a name, they do some other stuff, but most importantly, this stuff here, right here, this is the example that we would be using to regulate SSH access to the machine. Now, I think I highlighted this, yeah. So this basically says the instance should be allowed to receive SSH traffic that originates from this IP address. And presumably that block of IP addresses might be a VPN endpoint, or it might actually be some other set of machines on AWS, who knows. But the point is, we trust those machines and traffic coming from it. We also allow outbound internet access down here. That's because Terraform, so AWS by default allows outbound traffic completely, so you can talk to anything. Terraform strips that back off, and you have to put it back on if you want it. That's a good thing in general, because that means that you have to explicitly say, I'm allowing this machine to talk to the internet in general. This machine's actually behind a load balancer, so the only real reason why it needs to be able to do that might be to download operating system updates. However, if you were using an approach like immutable infrastructure, you wouldn't even need that, because you would make a machine, it would run its life. If it needed an update, you would make a new machine. We're not doing that. So, Terraform, we've got the config now, right? We've written out a few things. So how do you use Terraform? Well, the first thing you're going to want to do is ask Terraform, what would you do? Given this configuration, what would you do? And that is exactly what Terraform plan does. It makes a plan, and it writes it out to a file. You should always do that. Always write it out to a file. It's another early lesson from DevOps Consulting. You should definitely run plan first and save it and know what you're going to do. So Terraform plan examines the configuration, and then it examines the actual infrastructure, basically performs a diff, and says, what's different here? What would I need to change? In this case, Terraform responds, I have 10 resources to add, none to change, and none to destroy. In other words, Terraform thinks we're starting from scratch, which we are. So here is the output of Terraform plan. Please, in the back, raise your hand if you can't read it. Terraform is notoriously verbose. This is the actual output of it at 2-point font. I just kept the important last line here and made it big enough to read. But it really is the output from that. All right, so that's Terraform plan. Terraform apply. You then say Terraform apply, and you hand it the plan file. It executes the plan against AWS or wherever you're targeting AWS here, makes all the changes. And here down at the bottom, we have a happy outcome. Apply complete, 10 added, no change, no destroyed. Hooray! Now this run, I'm showing you on screen because this would actually take 2 to 3 minutes. Most of that time is spent spinning up the instance. And then going beyond that, we would have other work to do as well. Like the load balancer would have to notice the instances would have to register as being healthy. And then finally, the load balancer's DNS address would have to be propagated to me, which would take 5 minutes to 10 minutes. I didn't do all that, so I pre-baked the cookies. And this is what our money-making application says. It's a default Nginx screen. And we'll see how the profit comes to us somehow through this. I don't know. Anyway, now then, the whole point of the talk is not to give you a very brief introduction to Terraform, but to ask, how can we verify Terraform? So based on what you know so far, you would think the next thing I should do is run Terraform plan to find out, is there any difference between what I want and what Terraform would do to make it what I want? And the answer is here, there are no changes. The infrastructure is up to date. Terraform plan worked. Yes. Good work, everybody. All is well. Huzzah. However, meanwhile, let's say somebody goes into the console and makes, say, a security group that opens up port 22 to the whole wide world. And let's say that this person doesn't want this to be deleted, so they use a little bit of social engineering and give it a name that will make other people pause. Like say, I don't know, UAT executive, and do not delete in the description, that sort of thing. That way if you saw it, you'd be like, somebody might be depending on this, and I will get in a lot of trouble if I destroy it. So we make this security group. Remember, that's like a firewall rule. And then we attach it to the running instance. So now we've got this new rule attached to the instance. All right. What happens next? Can we audit this with Terraform plan? What will Terraform plan say? Well, it does a pretty good job. It looks at the instance and it says, I expected to find 2 security groups, 2 firewall rules, but I actually saw 3. That's funny looking. So if you let me apply this, what I would do is I would add nothing, I would change something, I would change that instance by stripping off one of its security groups, and then I would destroy nothing. So it would change one thing but destroy nothing. So it's going to simply detach the rogue security group. It's not going to destroy it. So that sounds good. It detected the instance, has a new security group, and would detach it. That's great. But I think it actually falls short. First of all, it only audits what's known in the Terraform config. Because the security group was created outside of the Terraform config, it really doesn't know that much about it. The only thing that it knows is that it was attached to this instance. It doesn't know if it's dangerous. It doesn't know that it was trying to open up port 22 to the world. So it doesn't tell us anything at all about that. It just says, hey, there's this security group and here's its ID number. Shouldn't be attached to this, so I'm going to yank it. Okay, well, the second thing that I think is a bit of a shortcoming here, and it's not really intended for this purpose, but as a provisioning tool, it will always be reporting these things to you as being configuration drift. And someone looking at this will usually have that mindset. They'll be saying, oh, I see a change here. Maybe that's to be expected, or maybe it's even flapping. Who here knows what flapping is? Cool, I'll give a quick definition. If you were to run an instance like this, and at the same time your ops group had like a auto tagging system installed, so that like whenever you create an instance, it stamps a new instance with your name or with the billing department or whatever. That's great. Whenever you run Terraform, it would say, I've got these 2 extra tags. I got to rip those out. And then it rips them out, and the automated tagging system retags your instance, and back and forth and back and forth. And so that's flapping. So if you have that situation, Terraform would always see some small change, and you would start ignoring the output of Terraform plan, because you would start assuming that, oh, it's always going to have some little change, who cares? That's bad. So if we use some other tool that really looked at things from a different perspective, and that should rarely fail, that would be advantageous. Finally, you cannot say a negative in Terraform. You can't say things like, I don't want any security groups, firewall rules, that are open to the world. You just can't say that. Because in Terraform, you're saying what you do want to exist. And Terraform's job is to make that exist. You can't write an anti-resource in Terraform. Sorry about the plosive. Right. So you can only express positive tests. So we need something else. I'm still trying to figure out if he's squirting him with something or if he's tickling him with a piece of anyway, point is, we need a Sheriff Andy. So, all right, let's talk about InSpec Shell, or let's talk about InSpec. InSpec can be that tool, and InSpec Shell is a great way of interactively demonstrating this. So, InSpec Shell, you just say InSpec Shell, and we target AWS right here, the -T with the AWS thing. I've got my credentials stored away in environment variables so that this just works without a whole bunch of other stuff here. But it gives you an interactive prompt here. It lets you do all kinds of cool stuff. Like you can say AWS_tab, and it will give you all of the many, 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 yet never enough resources that we have for AWS. And I see a couple nods out there. We're working on it. We've got 2 more this week. So, all right. So let's look at that rogue security group. We picked up the ID number off of Terraform plan, and we call AWS security group .group name. So let's find out some information about it. Tells us that it has this name here, which if I didn't know that was supposed to be there, that would just raise my eyebrows really high up. Because I'm like, what is that and why is it here? What are you doing? Next thing, let's ask it about its inbound rules. So what exactly are you doing to let things in? If there's a rogue security group, this would be probably the first thing I would look at. I mean, unless you want to go into the console or something, but you want to know the inbound rules. What is it trying to let in? And what it's trying to let in is port 22, which is very suspicious. And it's trying to let it in from the world, which is very bad. That's not okay. So here is how you would more formally and easily describe this. So if you were to write a test in InSpec to query this exact problem, you would say, describe this group, and reading it aloud in English, it should not allow in the IPv4 range 0000. And that's one of the best strengths about InSpec. It may or may not be easy to write. We try to keep it as easy as possible to write, but we try very, very hard to keep it easy to read. Our goal is that any auditor or compliance officer should be able to look at this and exactly read off exactly the intent of what it's supposed to do. So here's the result of running this. And is the red really hard to read in the back or anywhere? No. Well, I can't really change it now, so I'm sorry. I'll say this. Red either means string or it failed. So string up here, it failed down here. So it failed, which is what we would expect. All right, let's make this a bit more formal. Let's get out of InSpec shell, which is an interactive ephemeral experience, and let's make an actual control. So so InSpec controls are just Ruby files, and a Ruby file is just this right here. So first of all, I'm basically going to have the same code, but I'm going to wrap it in 2 layers of blocks. The outer layer, the control block, that's really just for nice formatting. So it'll give a nice description of exactly what we're trying to do. We're trying to say, make sure unrestricted SSH is not permitted, all right? The next block does something really interesting, all right? This is some cool stuff here. This right here, wait, do I have things on? I do. Hey, look at me. This next bit says, this is not a test right here, but it is relying on an InSpec resource. It's saying list all of the security groups, all the firewall rules, and then access their group IDs. So this is a global search for all firewall rules. And then for each one of them, we're going to loop over it, and then we're going to examine that security group in detail. And then, reading aloud, it should not allow in port 22 from the IPv4 range that represents the world. So that one code right there will scan your entire AWS account for any open security group that allows in port 22. There's a lot more you can actually do here. You can say different ports, you can say port ranges, you can say multiple groups of IPv4 ranges, you can do protocol, you can specify positions, lots of great stuff. I'm saying yay on that because I wrote that bit and I was very proud of it. All right. Okay. What do I do? I won't push that button again. All right, so here's what you do to run a set of save checks, assuming that we've saved those checks in a file. We're switching from InSpec shell to InSpec exec, but we still have the target flag there. We're saying target AWS, run this thing. Ta-da! Again, red just means something failed. As you can see, when I ran this, I had several security groups that were just fine, already existing. And I have one rogue security group that's failing. And that makes the whole control fail, you see. So, right there. So this is a test, and that's a control. So down at the bottom it says, I had no successful controls, I had 1 control failure, I had 8 successful tests, and 1 test failure. Yeah, so that's that. Cool. All right, where to next, Sheriff Andy? So, now that we know we can do this, and we can test negatives, we can look back at our configuration and say, what else would we want to test? So, we can nope, not you, there we go. We're already able to test the number and type of instances requested. Terraform plan can do that. So I would go ahead and let Terraform plan go ahead and do it. All these things, I would say go ahead and do it with Terraform plan. Now, just to put this out there, we have a brand new tool out called InSpec IGGY. And InSpec IGGY's job, it's a plugin for InSpec. If you install it, you get InSpec Terraform, which is a very exciting command. And its job is to look at a Terraform state file and extract out InSpec controls just for that. So it sounds great, but it doesn't do a whole lot right now. It only has knowledge that Terraform already has, which is my big complaint about Terraform plan, of course. So I would say using Terraform IGGY in the future, once it's a bit more fleshed out, along with some handwritten negative tests, you'd have a very good coverage. So, anyway, but let's look at some more things that InSpec can do for us. We can verify that all existing instances are actually part of our application, that there are no rogue instances. I'll skip down here, there should only be 1 load balancer. Cool. And this really complicated rule, the only security group open to the world should be listening on port 80, and it should be attached to the ELB. Cool. All right, so the load balancers, this is very simple to do. We just say, describe all the load balancers. How many of them are there? Its count should be 1. Comp is great. Comp is a very sloppy equality, is basically what it does. It is an equality matcher that doesn't care very much at all about type. And Ruby already doesn't care that much about type. So the implementation of comp is like this whole long list of rules of thumb. So if that was a stringified one, it would still match. So, or a symbolified, whatever. So. Instances, let's look at this. I'm covering the 2 simple ones first. Here we loop over all instances. We get out their instance IDs, and then we check each one of them in detail. So this is a very common pattern. You use a very simple plural resource like AWS instances, and the only thing you're interested in out of it is maybe filtering it down a bit, but the thing that you want out of it is the instance IDs or some other identifier, and then you run a loop over it, examining those particular objects in detail to ask it really hard questions. The questions we're asking here aren't particularly hard. What's your instance type? And do you have a tag named project with innovative monetization, which is how I had tagged it earlier. Now then, here's the neat one, the teasy part. What we needed was the only world open security group should be attached to the ELB and listening to port 80. So start with the load balancers, ask for all the security group IDs, got them there in an array, check. Loop over all the security groups and all of their group IDs, check. Grab a security group for examination. We have done no tests so far. None of these things are tests. This is all just data fetches. All right, next we say, if that security group allows in this open to the world range, then we're going to do more things to it. If it doesn't, if it's already restricted, we don't really care. At this point, we say describe, and we finally define a test. And we say describe that security group, its group ID must be in the load balancer security group IDs. So it must be attached to the load balancer or else you're in trouble. And finally, it should allow in only port 80. So we've got allow in up here. This is allow in only. So it says you must allow in port 80, but you're not allowed to allow in anything else. So, cool. All right. Put it all together with profile. How are we doing on time?
Keep going. It's 21.
It is what?
21.
All right. I'm a minute over. Cool. I will walk through this quick though. So a init profile generates a profile. It's just a directory structure for you. We would throw the files that we have made into the controls directory, and then we would execute it in the same way. This is totally way too small. I knew it would be, but anyway, you would still say InSpec exec, and then you would run profile. You would run the profile directory. It would know to look in there. At this point, I'll just throw in and say, you can also, if your company also needed all AWS accounts to be, say, CIS AWS level 1 compliant, you would also refer to that in the profile metadata. And then when this runs, it would actually run the entire company's check first and then run your check as well. So in that way, you can distribute and collaborate using InSpec. So that's important. You can split up the responsibility. You can have parts of your organization, like your security team, defining one set of things, and your application team defining the specifics, and then you know that your application will be compliant before you have to go run it and have them complain at you and give you a bunch of pieces of paper with red marks on it. All right, this is the wrap up. So we've got Terraform. It's a power tool for the cloud. It is, I believe, the best of breed for its job. Its job is to make things and to check that the things that it made were made correctly. That's awesome. It's not an auditing tool. A lot of people try to use it that way. Don't. InSpec is more broad-minded and gentle in a lot of ways. More like Sheriff Andy, I guess. That's a heck of a stretch. But they are best together, riding together in a crazy sidecar. Questions? That's a great question. Okay, so the question was, HashiCorp has a product called Sentinel, and you may have heard about this, and it is a competitor in the same space. And here are some of the things that differentiate InSpec versus Sentinel. First of all, Sentinel code is extremely developer-centric. When you read it, it is programming. It's yeah, it's very much written for the programmer. and more power to them, that's great. It also has much tighter integration with other HashiCorp tools, which could be a good thing or a bad thing. InSpec isn't integrated with anything else. It is integrated with Automate, but you can use it completely independently. Also, InSpec is a free and open source tool. Everything I demonstrated is completely free. You can use it yourself. It has an Apache 2 license. You don't have to talk to Chef or pay us any money to use it. Sentinel is enterprise only. So you have to write a big check to them to use it. So some of the differences between Sentinel and InSpec. Other questions? Thanks for asking that. I was expecting that. Thank you. Right, that's correct. The question was basically, how do we obtain the AWS credentials to talk to it? And we are relying on the AWS authored AWS Ruby SDK. So for the most part, we are using its mechanisms. So if you have credentials in a credentials file, that just works. There are bits that we have accidentally broken a little bit. You can use session tokens, that works just fine. The one piece that we know doesn't work perfectly in all cases is if you are running on an EC2 instance or an ECS task that has an instance profile associated with it that has an assume role built into it. We can't automatically pick up on that in all cases. In some cases, we can. It's an open ticket. We ought to fix that. Right. Thank you. I misunderstood the word profile to mean InSpec profile. I got you, yeah. So the question was, are you able to use different AWS credential profiles? And the answer is yes, that's actually how we built it. The intended easiest way to do it is, you can use the environment variables, put your keys there if you want to, that will work. But whenever you saw me saying AWS :// the full version of that is AWS : / region name / AWS profile name. If you put that in, it just works. So, assuming your profile works. I think I'm well over at this point. Yeah, I think I got 2 minutes before the next person's up. So, is the next person here? We have this next speaker?
Yes, he is.
Okie dokie. Do you want my mic? Okay. I'll be out in the hall if anyone has any further follow-up questions. Or I could just keep talking. Do the next one.